Good morning to everyone. I'm Dr. Sumiyamas. The topic of my today's presentation is multipliers from Unit 4 Interconnect Memory Architecture and Arithmetic Circuits. On completion, the students will be able to draw a 4-bit array multiplier and explain and also understand the structure of a ballast tree multiplier. This diagram represents a 4-bit array multiplier with inputs x and y and output p. Array multiplier uses an array of cells for calculation. Multiplier circuit is based on repeated addition and shifting procedure. Each partial product is generated by the multiplication of the multiplicand with one multiplier digit, and the partial products are shifted according to their bit sequences and then added. N minus 1 adders are required when n is the number of multiplier bits. And this method is simple, but the delay is high and it consumes large area while using a ripple carry adder for array multiplier. The product expression for an array multiplier is given below, where P is the output and X and Y are the inputs. This multiplier can accept all the inputs at the same time. An array multiplier for n-bit word needs n minus 2 full adders, n half adder and n square AND gates. So for a 4 cross 4 multiplier we require 8 full adders, 4 half adders and 16 AND gates. As in this given diagram, this diagram represents a 4 cross 4 array multiplier using full adders, half adders and AND gates. Ballast tree multiplier. A ballast tree is an efficient hardware implementation of a digital circuit that multiplies two integer numbers. The ballast tree multiplier has three steps to be followed. Multiply each bit of one of the arguments by each bit of the other, thereby yielding n square results. Reduce the number of partial products to 2 by layers of both full adders and half adders. Group the wires into two numbers and add them with a conventional adder. The ballast tree multiplier output structure is a 3-basis structure and it reduces the number of components and also the area thereby. So this diagram represents a 4 cross 4 ballast tree multiplier where we have initially the partial products obtained from the two inputs x and y, and at the first stage we have two half adders, and the second stage we have 4 full adders, and finally we have a conventional adder to obtain the final output. Quiz questions on multipliers. Construct a 4 cross 4 array multiplier with half adders, full adders and AND gates. Give a diagrammatic representation of a ballast tree multiplier. Thank you.